I'm Anil Kumar sharing with you application questions on implicit derivation. We are doing rate of change. A weather balloon with radius 9 meters springs a leak, losing air at 171 pi meter cube per minute. Find the rate of decrease of the radius after 4 minutes, right? So let's see what we are given. We are saying weather balloon with radius of 9 meters. So radius is given to us as 9 meters. Losing air at units are meter cube per minute. That means volume, right? So write dV dt. Sometimes it becomes difficult to figure out. You can go with the units. So volume meter cube. So we just write volume pi meter cube per minute. Does it make sense to you? Find the rate of decrease in the radius after 4 minutes. So t equals to 4. We want to find rate of decrease, that means, and that too of radius, dr dt, when t equals to 4. This is what we need to find. So when you read your question, first just write on the, you can say, one side, what is given, what you need to do, so that you can think about a strategy. That's the whole idea. Now the strategy is we should have a formula relating volume with R, and since it is a balloon, we'll assume that to be a sphere, right? So our assumption is that we're working on a sphere. And so we pick up the formula. Volume is 4 by 3 pi r cube. So that's the formula which we need to work with. Now, so we need to find few more values, but let's start with the formula and then we'll figure out what else we need to find. Okay, so let this be the approach that this time. So we are given volume, which is 4 by 3 pi r cube. Let's differentiate both sides with respect to time. So dv dt, and we find d dt of 4 by 3 pi r cube. So that is dv dt. And here 4 by 3 pi is constant. R cube means 3r square dr dt. So that's the implicit derivation which we have done. So we nearly got our answer. We have dr dt here, and we can always substitute t equals to 4, but we don't know at 4 what is r. This is what we need. So when you get to that stage, then also you can work out on what you need. So you need to find r when t is 4, correct? That is what is important, when t is 4. How do we find that? Now when it says the rate of decrease in radius is what we need to find, it says the radius, initial radius, r, let's say initial radius is 9 meters. Is losing air so many meter cube per minute. So in 4 minutes, how much volume will be lost? That is what you have to figure out. So let's find initial volume using this formula, 4 by 3 pi r cube. So 4 by 3 pi, r is 9 cube. Is it okay? Let's calculate this. So we do 4 divided by 3, okay, times pi times 3.14, okay, and then times 9 cube. So we get a figure. Let's write in decimals. So this figure is 305, let's keep it 3052.1. Okay, so that's the volume to start with. Now it decreases at this rate per minute. So in 4 minutes, how much will it decrease? So loss will be, volume loss will be how much? It will be 4 times 171 pi times 4. Is it okay? So that gives us, let's write down, 171 times 3.14 times 4 equals to, let's write decimal values, 2147.76. Actually, we could have just converted with pi, right? because pi's will cancel out. I didn't realize it earlier, but let's do it like this now. So if that much volume is lost, so what is the final volume? Difference of these two, right? So let's do that. So 3052.1 take away 2147.76, and that gives you, in decimals, let's write down 904.34. So that's the volume which we are left with. Now for this volume, what is the radius? What is the radius? So this volume, and we'll again use 4 by 3 pi r cube to find radius. So we say radius cube, well, we know this is the volume, so we'll cross multiply. So we say 904.34 times, so that's the formula, right? So we'll multiply by 3, divide by 4 pi, and then cube root. So multiply by 3, divide by 4 pi, right? That's why I was saying pi could have cancelled anyway. Multiply by 3, divide by 4 pi, and then we'll cube root it later. Okay. So we have this number, we'll multiply this by 3, divide by 4, and then divide by 3.14, since we were taking pi as this value. So whatever you get, we'll cube root it, right? So we get r equals to cube root of, let's say, 216. Is it okay? Okay, so now we do cube root of 216, and we get 6 as the radius. Well, that is a lot of calculations. There could be a shorter way also, but anyway, at least this works, correct? So we get r equals to 6 when, that is after 4 minutes. So this is very important calculation. So now let's substitute all this. We know dV/dt, which is 171 pi equals to 4 by 3. We could cancel 3's. Okay, let's cancel. 4 pi, r is 6, so write 6 square dr dt. Is it okay? Substitute the values which you have, and now you can find dr dt. So let's write dr dt as equal to 171 pi divided by 4 pi, 6 square is 36. Okay, and we can calculate this answer. Pi and pi cancels. Okay, let's calculate. So we have 171 divide by 4, and then we'll divide by 36, and we get our answer as 1.1875. Oh, it was not bad. 19/16, or whatever we had here, and the units will be meters per minute. Meters per minute, right? I have to add one more thing here. Now what you need to also understand is, when you write your answer, what you notice is that the rate of decrease, right? So the answer has to be that the rate of decrease for radius, we say rate of decrease of the radius is anything, let's write 1.1875 meters per minute, right? Now this is very important to write. The word rate of decrease is important, mainly because at times the approach could be, when we say springs a leak losing that much, then dV/dt we could take we could take this with negative value, right? So the alternate could have been, you start with taking dV/dt with a negative value, and that will result into a negative answer. In that case, so if you start with negative value, so option 2, which is you start with dV/dt with negative 171 pi, is it okay? In that case, you will write dr dt is negative 19/16, for example. Is it okay? Meters per minute. So that's an option. But if you're working with the statement decrease, you have to include that in your final statement to get full marks. Otherwise, this could be wrong. The answer will be negative of this. I hope this point is absolutely clear to you. I hope you understand and appreciate the approach which we have taken here. There could have been a simpler method, I think. We rushed into this. Anyway, if you find one, feel free to post it. Thanks for watching and all the best.